So next thing is how to factor with three terms. So three terms is that quadratic format that we've been looking at, that ax squared plus bx plus c. Now, I'm going to show you the slide, divide, and bottoms up method. And the reason I started doing this one is because there's all types of methods for factoring a trinomial. So essentially the formatting of finding the multiples of c to add to give me b, which is kind of how I set this table up over here, happens with any method, except for the fact that other methods you kind of got to do some GCF and writing it back together in GCF, and a lot of times I feel like students make little common mistakes with those. So I find that with this way, kind of like manipulating the numbers, the slide divide method, when you manipulate the numbers, it helps students eliminate some of those small mathematical errors. So, as like always, when I have a trinomial, which is three terms, I'm going to check for a GCF first. If I have a GCF, I take the GCF out, but the GCF is still going to be part of the final factored format. So, when I have a trinomial, it's called slide, divide, and I say bottoms up, but basically you're moving anything in the denominator up. So, first thing we're going to do is we're going to check for a GCF here. So, my terms are 3, 7, and 4, and then I have 2 x's, 1 x, no x. So, I can't take out an x, and then 3, 7, and 4 don't have anything in common other than 1. So, the slide. The slide is how we manipulate our numbers. So we're going to slide the A. So remember, the A is this first number right here, this 3. We're going to slide that all the way to the C and multiply them together. So once I do that, I'm left with x squared minus 7x plus 12. Now, why do we want to do that? Because it's going to help us actually figure out a combination of numbers, and those combination of numbers are technically the zeros or the roots or any of those things, but we just got to finish completing this whole process. So A times C. So I need two numbers that multiply to give me 12, because it has to multiply to give me that A times C I just found, but those same two numbers have to add to give me negative 7. So I just kind of create a little organization chart. So with 12, I got like 1 and 12. So right now I just kind of focus on the positives, and then I think about, okay, can I make one of them negative or both of them negative to make it work? So 1 and 12, there's no way to manipulate 1 and 12 to add to get negative 7. So that's out. So then the next one would be 2 and 6. So again, there's no way to manipulate 2 and 6 and add it somehow, whichever one be negative, and get that. So that's out. So the last combination is a 3 and a 4. Now 3 and 4 have that possibility as long as I can manipulate the numbers a little bit by making one or both of them negative. So in order to add 3, or I wrote 7. In order to add 3 and 4 to get negative 7, I would need to make both of them negative. So I would need to make this a negative 3, and I would need to make that a negative 4. So negative 3 and negative 4 give me negative 7. So negative 3 plus negative 4 does give me negative 7. But if I make those negative, I got to make the other ones negative. I need to check that that works. So negative 3 times negative 4 gives me positive 12. So that is my combination of numbers. So what I'm going to do is I'm going to write 2 parentheses. I'm going to break the x squared down into just a single x into 2 parentheses. And what I'm going to do is I have a negative 3 right here. So I'm going to say x minus 3. I also have a negative 4, so I'm going to say x minus 4. Now, a lot of students try to stop here, but if we start the slide method, we got to finish it. So we slid the A to the C, but we did that to manipulate the number. Now we need to undo what we manipulated. So what do? We're going to divide the original A back into the two numbers. So we're going to say negative 3 divided by 3 and negative 4 divided by 3. So right here we slid the 3. So once we get our combination of numbers over here and we write it, we need to go back and divide it into both of them and get back to where we were originally. And simplify. So x minus 3 divided by 3, that's going to be x minus 1. Now, I cannot simplify 4 and 3. Okay, 4 divided by 3 is going to give me a decimal, and these are already in simple format. So I cannot simplify that 4 over 3 anymore. However, the last part to get it to look nice and pretty is to move any denominators up in front of the variable. That's the bottoms up part. So when I say bottoms up, that means anything left in the denominator, move it up in front of the variable in that parentheses. So my final factored form here is x minus 1, and then we move the 3 up, so that's going to be 3x minus 4, and that numerator stays there. And I could reverse the order if I wanted to. Both of these mean the same thing. Okay, that's that product property where if I multiply this one here, this one first, and then this one, or that one first, and then that one, it's the same thing. Okay? All right. So for number 10, we're going to go through this process again. So I have negative x squared minus 8x plus 20. Now, right now it doesn't look like we have a GCF because I have a 1, a negative 8, and a 20. However, that negative in front is drawing my attention to the fact that I'm going to take that out as a GCF because I have that leading coefficient. So whenever you do that, whenever you have that negative, make sure you pull it out in front of the problem and divide it out. So negative 1 divided by negative 1 creates a positive x squared. A negative 8 divided by negative 1 is going to give me a positive 8x. And a 20 divided by negative 1 is going to be negative 20. And what we're going to do is that GCF is still part of the problem, but we're going to focus on the trinomial that's left in the parentheses that we need to factor. Okay, so that method that we talked about is slide divide. Now this one's going to be a lot easier because technically my a value is now a 1. Okay, so if I slide that 1 over to the negative 20, it's not going to change anything. We still have negative 1 x squared plus 8x minus 20. And if I have to divide, or when I go to divide, dividing by 1 is not going to change anything. So we actually are left with negative 20, and my b value is 8. So I need two numbers that multiply to give me negative 20. But those same two numbers, when added together, give me positive 8. So again, I start at the beginning, 1 and 20. 1 and 20, there's no way that you're going to get 8 out of that. So then we got 2 times 10. So I'm pretty sure I can make 2 and 10 work as long as we can get the negatives right. So remember, I can put a negative on the 2, I can put a negative on the 10, or I can put a negative on both. So we want a positive 8. So in order to get a positive 8, we're going to put the negative on the 2. So we have negative 2 plus 10, that does give me 8. And then we have negative 2 times 10. So negative 2 times 10 does give me negative 20. So that's going to work out for us. So that negative 1 doesn't go away. That's still the GCF is still part of the problem. So we're going to put in parentheses and we're going to say x minus 2 because it was negative 2. And then x plus 10. Now, if we would go back to our method, the slide, we slid it over, then we divide. Well, technically, we slid a positive 1. So if we slid a positive 1, dividing by 1 is not going to change anything. So this is my final factored form. Whenever you have an a value of 1, all of those extra steps of the slide and the divide you don't have to wind up doing them because your final format it's not going to change anything if you slide a 1 and multiply it over or divide the 1 back out. And I'm just going to go back over here and I'm just going to box the correct answers for the notes. All right, so then we have number 11. Number 11, I'm checking. I have a 2, a negative 1, because that's technically a negative 1 and negative 6. So no GCF here. So we're going to start with the 2, and we're going to slide that over and multiply it in. So this is going to be x squared. I'm going to just go ahead and write minus 1x, and then minus 12. So I need two numbers that multiply to give me negative 12, but those same two numbers add to give me 1. So 1 and 12, that can't work, so that's out. So we have 2 and 6. There's no way 2 and 6 can add together to give me 1. And then we got 3 and 4. So 3 and 4 are 1 apart, so we can make that work. We just got to figure out what to do about a negative. So we need negative 1, so we need to make that negative 4. And we should be able to see 3 plus negative 4 does equal negative 1. 3 times negative 4 equals negative 12. So I'm going to come back over here, and I'm going to write them in the parentheses. So we're going to say x plus 3, and then x minus 4. Now, we did slide a number other than 1. My a value was a 2. So remember, the next step would be divide. So we're going to divide that original a back into both numbers. So my original a was a 3. Or excuse me, my original a was a 2. So we're going to divide it into the 3 and the negative 4. And then simplify. So 3 and 2, we can't simplify that any further. All right, negative 4 and 2, we can simplify that to negative 2. All right, so last step would be anything left in the denominator. We're going to move that up in front. So this is going to be 2x plus 3 and x minus 2. And again, if you want to kind of check this and prove to yourself, you could always multiply this back out. And it will, in fact, give you the same original trinomial that we started with. Okay? All right, so number 12. Oh, I have two number 12s. So for number 12, I have negative 3x squared minus 21x minus 54. So I absolutely have a GCF of 3 because I can divide 3 out of both of these, but that negative in front, I need to go ahead and factor that out with the GCF 2. So negative 3 divided by negative 3 is going to be positive 1x squared. Negative 21 divided by negative 3 is going to be positive 7x. And then 54 divided by negative 3, that's going to give me negative 17. All right, and once I divide those out, I should be able to look at the inside piece right here. And actually, I just realized I made a mistake. Not 17, that should be 18. All right, so we're going to look at the inside, and we're going to be looking at this part right here. That GCF is still going to be part of the problem, but that doesn't mean that it actually is going to go away. But this is what we're going to factor. Now, my a value is now a 1. So even if I slide that a value over, it's not going to change that negative 18. So we're looking at multiples of negative 18 that add to give me 7. So again, 1 and 18, there's no way to get 7 from that. So then we have 2 and 9. So 2 and 9 are 7 apart. And we want a positive 7, so we're just going to make the 2 negative. Now again, remember, you can make one of them negative, you can one of the numbers negative, or you can make both of them negative depending on what you need as your numbers. So we're going to write those back in. So we're going to say negative 3, I have x minus 2, and then x plus 9. Do not forget that I need to make sure that whatever number I supposedly slid, which was a 1, I divide it. Now again, dividing by 1 is not going to change this problem. So we're actually done, and I don't have to finish the rest of the process for my factored form. My GCF, whatever GCF, or if you have a GCF, if you wind up taking out a GCF, that is always still going to be part of your problem. All right, and last one. So always check for a GCF. So I have 3, 6, and 24. So we obviously have a 3 for my GCF. For this one, though, I have an x cubed, an x squared, and an x. So I can actually take an x out of each of these. So we actually have a GCF of 3x this time. So 3 divided by 3 is 1. I had 3 x's. Okay, so I have 3 of them, but I took one out. So that leaves me with just 1x squared. So then I'm going to say negative 6 divided by 3. That's going to give me negative 2. I had 2 x's, but I took one out. So that leaves me with 1. So that's going to be negative 2x. Then I have negative 24 divided by 3. So that's going to give me negative 8. And I had one x right here, but I took that one of those x's out with the GCF, so I'm left with none. So again, we are going to focus on the x squared minus 2x minus 8. And there is a 1 in front, so again, if I slide that over, that's not going to change anything. So we're looking for two numbers that multiply to give me negative 8, but add to give me negative 2. So for that one, we have 1 and 8. There's no way to get 1 and 8 to work to get 2. Then we have 2 and 4. So how do we make 2 and 4 work? They're 2 apart. So I need it to be negative, so we're going to put a negative on the 4. Just check yourself. So 2 plus negative 4 does give me negative 2. 2 times negative 4 does give me negative 8. All right, so I have 3x. And I'm going to do 2 parentheses. I have x plus 2. And then I have x minus 4. Now, again, I did technically say that I multiplied the 1 over, but dividing by the 1 is not going to change anything. So I'm done with this problem. I have my factored form. Okay. And actually, I forgot to change that to a number 3. So if you will, just on your notes, if you printed these out or if you're writing them, we need to change that to number 13. I duplicated the numbers. So again, when you're factoring, don't forget when you're factoring that you've got to check, or first ask yourself, how many terms do I have? Always check for a GCF. And then once we do that, what method is going to be the best method depending on the number of terms and what happened when if I did have to take a GCF out. I'm going to do one more example that's got a little bit bigger set of numbers. So I got 6x squared minus 25x plus 14. So I can see that I don't have a GCF here. I'm going to take that 6, I'm going to slide that over to the 14, and I'm going to multiply that together. So if I have 6 and 14, that's going to give me x squared minus 25x plus 84. Okay, so we need to find two numbers, and we need two numbers that multiply to give us 84, so that are going to give us the a times the c, which is 84, but we need to add to get the b, which is going to be negative 25. So obviously I could do like 1 and 84. That's not going to be close enough. So then I have 2 and 42. That's not going to be close enough. So what happens when you're kind of struggling to think about what other multiples that you have? So I'm going to pull up Desmos, and I'm going to just kind of start dividing 84 and see what I can find. So obviously with 3, I have 3 and 28, and we're looking for it to be 25. Well, 3 and 28 could potentially work. So let's see. So we have 3 and 28, and then 3 plus 28. So we would have to make that 28 a negative. So here's where an issue comes in. So if I do 3 plus negative 28, that does give me negative 25. But 3 times negative 28, that's not going to give me positive 81. And I need positive 81. All right, so I'm going to go back to Desmos, and I'm going to kind of see what else I can find. So we have 4. So we have 4 and 21. That could work. So we have 4 and 21. We got to check our negatives. So this time I need to make the 4 and the 21 negative so that I can add these two together to give me negative 25. So let's check the multiplication. So I have negative 4, negative 21, and then negative 4 times negative 21 does add to give me positive 84. So I'm going to write those two. So I have x minus 4, and then I have x minus 21. Now, when we're doing this, we've done the slide. Now we need to go back and we need to divide. So we're going to go back and divide the number we slid. So the number we slid was 6. So we're going to divide that a back out so we can undo that manipulation. And we're going to simplify. So 4 and 6 are both divisible by 2. So if I simplify 4 over 6, that's going to become 2/3. We want to simplify every time. And then we have 21 and 6. So 21 and 6 are both divisible by 3. So that's going to simplify to 7 over 2. All right, and then our last step is anything left in the denominator. So we have a 3 in the denominator and a 2. So we're going to take that 3, we're going to move it up, and we're going to take that 2 and move it up. So this is going to become 3x minus 2 times 2x minus 7. Now, if you need any help with this, please don't hesitate to contact me.